Keep finding all those Raspberry Pi based gadgets around the office and you're going, is this secure? Stay tuned to find out how to secure them.
You're watching ITProTV.
Happy Pi Day, everyone. And well, we're going to be talking about securing the Raspberry Pi, but you know what? I think we should set some context down before we get too far down the road. I don't want to steal your thunder, but the reason we thought it was important to talk about this is, well, Tim came to me one day and was like, hey, Justin, I've got this new gadget. It's cool. It's this little weather flight, like weather data for like airports, right? And it has green and blue and red. And this is the exact device. And it goes, it pulls data and it lights up and it tells you wind speed. And it goes, and it runs on a Raspberry Pi. And I go, What? Is it on our network? And he goes, yeah, it gets the information from the internet. And I go, oh, what's the IP? So I do a quick scan of our network and I go, oh, here it is. Does it use default creds? Not the original Raspberry Pi default creds, but default creds for the product. It was open. I could escalate privileges. And then I was like, oh, you got to update it. And he was like, what am I doing? I was like, yeah, I don't know if Don's going to be so happy about that. But it's things like this. This is a pretty cool project. But then it opens us up to, hey, I now have access to a piece of software that maybe Don doesn't know about, I don't know about, just because it's cool.
Yeah, and with most networks running DHCP, it's not uncommon for people to buy these simple, maker type projects. They bring them in, they plug them in on the network, and now you've got a machine that is terribly insecure, and it's in your environment. Now, you could go a little draconian and say, that's it, no unauthorized IoT devices, I'm going to put my foot down and that's it. But I'll tell you, I love Raspberry Pis, and they are super convenient. If I need to whip up a quick web server or run a little experiment, I use Raspberry Pis all the time. You can make them more secure. They are pretty weak in the area of security by default, but that's because it's really a research device, a testing device. It's not designed for production use. But tons and tons of people are using them now. I've seen a little projector software that was used for mirroring a whiteboard that ran on a Raspi. This general aviation map that uses a Raspi. Clocks, all sorts of things that use them.
Cars. I've seen them, people install them in cars for graphical user interfaces for a variety of sensors and stuff.
Definitely want to trust your driving safety to it. So while it is not very secure by default, there are a handful of steps we can take to actually secure them. So in this episode, what we're going to do is we're going to talk a little bit about some of the basic configuration settings that we need to change in a Raspi. We'll talk about updates and how we can manage those a little more appropriately. We will talk a bit about configuring a firewall to limit the traffic that's able to get to it, as well as securing SSH so that we can only do trusted management remotely. And we'll talk about a few other security things like using trusted certificates for web services, all on the Raspi. It's pretty easy to do if you just remember these handful of steps.
Now, Don, you said some things where I'm like, ooh, this is going to be nice. This is going to be a nice how-to. But before we get too far into those more advanced topics, we probably need to take a look at those basic steps. So what are those basic steps we need to take?
Absolutely. When you install a new Raspi, right, the recommended operating system for it is Raspbian. And you can get that from the Raspberry Pi project. And you flash it on an SD card and you boot the system up. And their recommended first step, the first step most people are going to do, is to run the Raspi config script. So let me bring that up. So I'm connected to my Raspi here, and I'm just going to do a sudo raspi-config. And so when I run that, I'm taken into the Raspi configuration. This is a Raspi, I cannot say it, a Raspi Model 3, or Pi 3 Model B. And if I go in, you'll see a few things like changing the password for the Pi user. The default username is Pi, the default password is Raspberry. Everybody knows that. Every hacking tool on the planet has that as a default cred loaded into it, and it is going to try to use that to access your system. At a minimum, you need to change that password. And so we can just do that right from here, easy enough. And so I'll go in, and it's going to ask me to punch it in. I need my new password. I will punch in what I want that new password to be, and so now that one's fixed. Another thing that we can do in here is to enable SSH. I don't want to have to hook a keyboard and a mouse up to this every time I want to go and manage it, or just a keyboard or whatever. I want to be able to SSH into it. And it's turned off by default because of security, but we can turn it on in a way that keeps it secure. So I'm going to go down to interfacing options. And under interfacing options, I'll go to SSH. And inside of SSH, you can tell it to enable the SSH server so that you will be able to connect automatically on the system. And it warns you, Default and weak passwords are a security risk, so that's going to be left up to you. Okay, so when that's done, those are the main things I need to configure here. There are a few other things like localization options. You'll want to make sure you get it set for your proper keyboard. I run into this one all the time because it defaults to a UK keyboard. And when I type in a password with special characters, the @ symbol is the double quote symbol on a UK keyboard, so it's messed up. If I switch it to a US keyboard, now all of a sudden the password works properly. So you'll want to set those kind of things and get them in place. All right. After that, now I've got my basic stuff kind of set. There are a few more things I want to do. I know that Pi account is always there, and the hackers know it's there too, so I don't want to use the Pi account. I'm going to create a new account for myself. So I'm going to say sudo add user, and I'll create an account for me, dpossett, right? So I'm going to create one. It's going to ask me for a new password. I'll punch in what I want that password to be. And once I've got that, now it's going to ask for additional information. If I want to type in my full name and other things, I can specify whatever. I'm going to leave most of these blank. And then I'll just say yes to get that user created. So now I've got a nice little user account. Now I do want to be an administrator, so I'm going to follow this up by saying sudo gpasswd-a. I'm going to add dpossett to the ADM group. That's going to make me an administrator. And then I'm going to add myself to the sudo group so that I'll be able to use the super user do command, which I've been using already to make sure that I'm able to execute admin commands. Now when that's done, I'm now an administrator. My user account is administrative. So I should be able to do pretty much whatever I want on the system and even get rid of the Pi account if I want. I could delete the Pi account or I could just lock it out if I'm not going to use it anymore. But before I do either of those things, I need to test to make sure I can actually get in with my account. So I'm going to open up another shell here and I'm just going to SSH into that system as myself. So I'm going to connect into what that IP is and punch in my password, and there we go, make sure I can get in. And I'm gonna make sure that I can use the sudo command just to verify that it is working before I go and mess with the Pi account, right? You don't wanna mess with the Pi account if you don't have alternative credentials. Then back in my original window, I'm gonna exit out of that one. I don't need that Pi user anymore, so I just need to kind of get out of that one. And back as dpossett, I can disable the Pi account. I'm gonna do that by issuing sudo passwd-l Pi. I'm going to lock the user account. I prefer to lock the user account than delete it because there are some software packages written for Pi that depend on that Pi user existing. They shouldn't, right? It's poor programming practices, but people still do it. So that's why I like to keep the user account around. And so by doing that, I've now locked the Pi account and nobody can log in as that one.
Now, Don, I was actually getting ready to ask you, I was like, well, why are we locking this out? But I've run into that where it's almost used as a service account. If you're building new software, please don't do that. Don't do that. You need a new service account just for that application that's running. But removing that can cause a whole bunch of whoopsie-daisy on certain things.
Yeah, and if you poke around in the services, you might find some that are set to run as Pi. They shouldn't, right? But they could. And you might find some scripts or whatever for software that depend on the account. That's why it's usually a little better. Just lock it and leave it there. All right, so now that I've got my user accounts kind of situated, I might want to tweak how sudo works. I don't like having to enter in a password every time. It is a nice safety measure, but I've already had to log in. I manage this remotely, so I may want to turn that off. So I'm going to do a vi-sudo, and I'm going to edit the /etc/sudoers file. Sorry, not sudoers. I need to edit, well, no, actually that is right. Hang on, let me just do vi-sudo by itself. And, permission denied because I need to sudo the vi-sudo command. There we go. And this is controlling how that sudo file works. And I want to add an extra entry in here. So I'm just going to go to the end of the line. I'm going to say dpossett, and I'm going to say that I'm allowed to run from any workstation. So I'll say from all workstations, I'm allowed to run all commands. And then I'm going to tell it that I don't need a password for all those commands. So no passwd::all, no password all. By setting that, I still have to log in with a username and password, but once I'm logged in, I'll be able to use sudo without having to provide the password every time. So that's a kind of a handy thing to do. So I'll get that set. And so now when I do a sudo who am I, well, it's probably cached from before, but even if the cache had expired, I wouldn't be prompted. Now I've got my user account situated, I'm logged in as my own account, and I'm ready to move on to the rest of securing the system.
All right, speaking of moving on to securing the rest of the system, one of the things that I told Tim, you need to do this immediately. You need to go ahead and run updates because that Raspbian image is at a certain snapshot. You may not have the most up-to-date packages. So I'm
Absolutely.
guessing that's where we're going next, right?
Absolutely. Yeah. It's not OpenBSD, right? They're not focused on security first. They are focused on just making a flexible maker device. So we need to apply updates. Now, you can do updates manually, right? I could come in and say sudo apt update, and then I'll do a -y and pass that with a double ampersand into sudo apt upgrade -y. So I want to do an update to get all the latest packages and then upgrade to actually install them. So if I run that, that's going to churn through and do my updates, right? So that's cool, right? But that's just one time. So I'll know that I'm up to date now. But what about next week? What about the week after? Especially if this is a map hanging on the wall. When am I going to log into that to apply updates? I'm going to forget about it, right? I'm just not going to think about it. So what we need to do is set ourselves up for automatic updates. Now, on a critical device, you don't normally do automatic updates because you want to make sure you test them and it's not going to break your software. But a Raspberry Pi shouldn't be a critical device. So it's pretty safe to turn on automatic updates here because even if it breaks what's running on that system, it's not the end of the world. If this map breaks, we can still get the flight weather data some other way. Okay, so I'm going to interrupt this update. Let me just Control-C out of that. And then I'm going to go in and I will actually apply automatic updates to do it instead. So I'm going to install a little package. I'll say sudo apt install unattended-upgrades. And this is a Debian package that's available that will use cron jobs to periodically, once a day by default, go in and apply updates for me. So I can just set this to run automatically, and as it does it, I know my system is up to date. I know that every day it's checking and applying those updates. It's kind of a neat system. Now, if I were running actual Debian or actual Ubuntu, I'd be done. You just install the package and it runs every day and that's it. But on a Raspberry Pi, it has a different system identifier. So just installing it is not enough. I have to go one step further, okay? I need to edit a file. So I'm gonna use sudo edit, and I'm gonna edit /etc/apt/apt.conf.d/50 and
I think you got a dash. It should be a dot after app.conf.
Yep. There we go. That'll
They
stop
are
me.
tricky.
Thank you, sir. 50 unattended-upgrades, that file right there. That's the job that basically it's going to be looking at to determine how often it does the updates and what kind of updates it grabs. And when I edit that file, what you'll see in here is a big list of the types of things it's going to look for. And as I scroll down right here, these two lines are currently what's going to be applied as far as updates. Notice it's looking for updates for Debian and updates for Debian security. All right. It's not looking for Raspberry Pi. The strings for that, I've got them in the background here. Notice that distro name, Raspbian. Raspbian is different than Debian, so it's a bit of a problem. So I'm going to copy and paste these, and you can find this information right on the Raspberry Pi website, or I'll try and make it available through another means, maybe in the comments or something. But I'm just going to copy those, and then back here in this file, I'll just take the very next line and paste that in. And, I've got my space syntax wrong, which will drive somebody like Justin crazy.
Oh, yeah, I was going to say, please don't save that until you fix that.
All right, so I'll fix that. So now we've got our OCD side taken care of. You can actually comment out the Debian ones or leave them. It doesn't hurt, so I'll just leave them and set that. So when I save that file, now my system is set to automatically apply these upgrades, and cron will take care of that, right? It'll run every day. It'll find those updates and get them applied. So now I don't have to worry about it. I haven't done updates now, but if I just wait, by this time tomorrow, it'll be upgraded. And then the next day and the next day, all taken care of.
Now, Don, I've actually tried to create my own cron job to do this. This is way easier, so definitely go that route. But, early on, we enabled the SSH service. But there are times where I've found, depending on what I've installed, there's other services running. We don't want services just hanging out in the background, right? So should we turn those off?
Absolutely. So when you go to download Raspbian, there's actually 3 different versions of it. There's a workstation version, there's a server that's got a ton of stuff, and then there's a minimal install. I always use the minimal install because then I just add the pieces that I need, so it's pretty streamlined. But if you grab the desktop install, for example, it's got a GUI and all sorts of other components. It likely has stuff you don't need. And if you don't need something but it's running, that makes you vulnerable, right? It increases your attack surface. So you should identify the stuff that you don't need and get it turned off. So one way you can do that is by using the systemctl command. If I do, actually I don't even need sudo for this. You can just say systemctl --type =service. If you run that, that will give you a list of all of the services that are installed on your Raspberry Pi, and you can see their status of whether they're active or not. It can be a big list, and so sometimes I filter it a little more and say, you know what, just show me the ones that have a state of active. So I'm going to add -- state equals active. If something's disabled, I don't care. It's disabled, right? So that'll filter it out a little bit. But I can look down this list and try and find things that I may or may not need. So for example, the ALSA state service is running. ALSA is a sound card driver. Well, this is a little mini server for me. It doesn't make sounds. I don't need a sound card driver. I could turn that off to help reduce that attack surface. Bluetooth. I'm not using Bluetooth on mine. So I could turn that off. You'll find a lot of things in here that you may or may not actually be using that can make a big difference. And for me, Bluetooth is one of the big ones. If I'm not using it, I'll typically turn it off. You can do that through the Raspberry Pi config command as well. A few other things in here like rsyslog. I like rsyslog because I can export my logs to another, like a centralized server. But if I'm not doing that, it is just one extra process that's running. So go through here, take a look, and when you find a service you don't need, all you're going to do is say sudo systemctl disable and then the name of the service that you don't need. I'm not using Wi-Fi, so I'm going to disable the WPA_supplicant.service. And so when I disable that, you'll see it removes the links for it, systemd stops it, and now that's not going to be loaded with my system anymore. When I power on next time, I'm not going to have any wireless support. And if I change my mind and I want it back again, I can always just come back in and do the same thing but with enable and turn it back on. So you can't really hurt yourself too bad unless you, I don't know, lock yourself out of the machine.
And this is one of those things where disable is a little bit different than stop, because disable is actually going to stop it, but also remove it from turning on a restart, right?
True. So I actually don't use stop anymore. Well, if I'm doing something like this, if I want it to be permanent, what I'll usually say is like enable -- now. And that says I want it to turn on when I boot up, but I also want it to turn on right now.
Okay.
Or disable -- now. I don't want it to turn on when I reboot, and I want it to turn off right now. So you can do that, kind of knock it all out in one command. Yep.
Okay.
All right, so let's see. We talked about system updates. We talked about unused services and getting rid of those. There is one service that I really like to have, but don't by default on a Raspberry Pi, and that's a firewall. Justin, you mentioned that when you heard about that map that was brought up, you scanned the network and found it, right? What did you find when you scanned?
It's like it had a very particular, and it was like METAR or something. I go, oh, well, that's probably, if I knew anything, right? I knew about devices and I was looking for those. That's an immediate, hey, I think I could go find a document or a manual that might have default creds. It's kind of like finding a Linksys or a Netgear router that have default creds. Boom, I'm in. So I shouldn't just be able to hammer it with traffic like that.
And the MAC address of the device gives it away as being a Raspberry Pi 2. They're pretty easy to spot on the network if you're looking for them. So if we want to protect them a little further, we should turn on a firewall. A firewall will help to prevent people from accessing and give you a little control. Thing is, though, we don't want to go crazy with the firewall because it can really make it difficult to get custom open source software running through it. So I recommend using a simple firewall. Actually, no matter what firewall you use, most of them are just using the NF or the net filter service in Linux. So they all kind of use the same technology under the hood. It's just the interface that's different. There's one called UFW, or the uncomplicated firewall. It's small, it's easy to install, and it's simple to use. So if I want to restrict my system, so right now I'm just running SSH and that's it. I want to block everything else. I don't want other people scanning me. Well, if I did a netstat-an and looked at everything that was on my system, or maybe if I filtered it to listening, I've got several things that are listening right now, like my journaling system. Looks like System Bus is doing its thing. DHCPD is listening. I've got several ports that are open that people could potentially connect to my Raspberry Pi with. So I'm going to install UFW to take care of that. I'll say sudo apt install UFW-Y. So I'm going to install the uncomplicated firewall. And once it's installed, it's not actually working yet, right? That installs the tooling. And then what I'm going to do is configure a few basic rules. And once I've got the rules in place, then I'll turn it on. Be careful with this. I'm SSH'd in right now. If I configure this wrong, I could lock myself out. So it's a good idea to be physically connected to the Raspberry Pi when you configure it, or be able to be physically connected.
Yeah, I have to admit, I've locked myself out a couple of times. The order of this is very important, so pay attention.
Yeah, absolutely. So I've installed it. So now what I'm going to do, I'm not going to turn it on yet, right? I'm going to say sudo UFW allow, and I'm going to tell it what I want to allow. I want to allow port 22/TCP. SSH uses TCP port 22, so I'm going to be allowing that. Now, I could stop right there, but I like to add a comment so I can remember what the stuff is. So I can, whoops, oh, darn it, there. In quotes, I'll put SSH, or spell it wrong. I spelled an acronym wrong. That's embarrassing. So SSH is what I'm going to put in there, and that way I can remember what this rule is. You know, as you add more and more ports, maybe I've got a custom web server running on port 8080, so I might want to come in and say that I want 8080/TCP, and for the comment I put like Don's experimental web server or whatever, so I can just remember why I even made that. Comments are really handy. Okay. Oops. Oh, it's not going to like my little single quote. Let me get rid of that. There we go. And so now I've got that rule in place, and you can see your rules by doing a sudo UFW status. Oh, actually, since mine's not running, it's probably not going to do it. Yep. So it's not going to show me, but I've put the rules in place. And I've allowed SSH in, which is good, right? So if I turn this firewall on, I should be pretty safe, unless I messed up the rules. So I'm going to do a sudo UFW enable, and that's going to turn it on, okay? And I'll say yes. So I'm going to let that, it's warning me, it might disrupt your connections. The reality is if you already have an SSH connection open, it's pretty rare that it'll interrupt you. But if you disconnect, when you reconnect, that's when you'll end up with a problem. So it looks like I'm okay. I'm going to do a sudo UFW status, and there's my rules. I can see the port 22 and port 8080 for IPv4 and IPv6 are both on. There's my comments. Looks good. I'm going to open up another window, and I'm going to try and SSH in just to make sure I can still get in. This is really the proof of whether or not I'm able to get in, and it looks like I am because I got prompted for a password, and I'm in. Okay, so my firewall rule is good. I didn't lock myself out. That's nice. And so now I'm into the firewall. So UFW, easy to turn on. You can add whatever software you want to it. And now when somebody scans your system, they will only see the ports you want them to.
Just a quick reminder, you add any services, maybe you set up a mail server, whatever, make sure to update your firewall rules or you'll be trying to figure out why things aren't working. Speaking of SSH, I know that sometimes needs to be locked down a little more, just because it ends up being this attack surface that's maybe unnecessary, or you're allowing like brute forcing and things against it. We should probably address that, right?
That's right, Justin. You know, somebody scanning is still going to find SSH. They know it's a Raspi. They're going to try that Pi user. They can start brute forcing passwords to get in. I want to restrict that. And even worse, maybe I need that Pi user to still be active because some service depends on it. So I couldn't lock it earlier. Well, I don't want to allow Pi to SSH in. I just want to allow me, deep as that, I want to log in, and that's it. So we can come in and restrict that too. So let me show you how that's done. What we're going to do is we're going to modify our SSH configuration. So I'm going to use the sudo edit command, and I'm going to edit /etc/ssh/sshd_config. And in that file, you'll see a lot of information here about SSH and its configuration. You'll see like the port number. Some people like to change the port number so that it's harder to find SSH, but it's really just security through obscurity. I don't normally worry about that one. But you will find an authentication section, and here's where you can say like, I don't want to do password authentication. I just want to do certificate authentication and things of that nature. Certificate authentication is really not that hard to set up, but it is a little bit of overkill for a maker project typically. But one thing I'll do is I'll come in and I'll add an entry that says allow users, and then I'll specify what users are allowed to SSH in. In this case, I'm going to say dpossess. If I had more than one user, like I want to allow Justin, I would just say comma Justin and continue to add that list. By just putting me, I'll be able to SSH in. The Pi user can't. Any other user can't. I'm now the only one who's allowed to use SSH. So I'll go ahead and save that file. And that doesn't take effect until I restart SSH, so that'll be a piece. But before I do that, there's another thing I can configure. I'm still allowed to use SSH. So what if somebody knows my account? You all watching know I'm using dpossess, so you could try and brute force my account. So it would be a good idea to set up some brute force detection. I'm going to install a service called fail to ban. I'll say sudo apt install fail to ban, fail the number 2 ban, and I'll do a -y. So that's going to install. And what fail to ban does is it watches the log files on your system. And if it sees somebody continually failing to log in, it can add a firewall rule to block their IP address. So if somebody gets it wrong 5 times in 60 seconds or something like that, they get blocked at the IP level, and now they're not able to access your system at all. It's a great way to protect things, and it's super easy to do. Once it's installed, you need to edit its configuration. So I'm going to do sudo edit /etc/fail to ban jail.local. All right. Jail.local is where you put your configuration. Don't modify the other configuration files because they get erased whenever you do an update. That stinks to lose your config. So here we define exactly what we want to do. And so I'm going to start off with my default values. So I'll just type default in square brackets. I'm going to say ban time equals 1 hour. If somebody gets banned, I want to hold them out for an entire hour. That'll usually stop a brute force. And then I'll say ban action equals UFW. This line's really important because the default action in fail to ban is to use firewall CMD and the regular firewall service to stop it. But on a Raspberry Pi, we don't have that. So we need to use UFW for it. Then I can tell it the service I want to protect. I'm going to protect SSHD. And with SSHD, I'm just going to say enabled equals true. And that's it. Fail to ban is SSH aware. You can use this with HTTP, SMTP, your various mail protocols. You can protect each of those. FTP, SFTP, all the above. It can do brute force detection on any one of them. So once that's in place, I can get out of that configuration. And now we can just do the sudo systemctl restart. Actually, I need to do a enable -- now fail to ban. And so we're going to get that one turned on. And then once that one's on, I can do a sudo systemctl restart SSHD and restart that one. Now notice how I restarted SSH and I'm still connected. That goes back to something I mentioned earlier, which is a lot of these changes don't affect existing SSH connections. So before I mess around anymore, I'm going to open up a second window and I'm going to make sure that I can still SSH into the Raspberry Pi, and I can see that I can. I'm in there, right? Now I'm going to try and brute force it. So I'm going to try and SSH in this time, but this time I'm just going to type a wrong password, and so that's going to fail. Eventually I'll try it again, and that's going to fail. And if I get it wrong enough times, I'm going to trigger the brute force warnings, and it's going to create a firewall rule to lock me out. Now that's going to actually lock me out of the Raspberry Pi for an hour, which is going to really kind of designate the end of the show. But right there, so I just got the password wrong a 5th time, and that triggered the excess. And so now a firewall rule has been put in. I've been blocked out, so I know that's working. I can't communicate. And back here, this session is dead as well. Firewall rules are way more effective at shutting this stuff down than modifying SSH. But at this point, SSH is pretty secure.
All right, Don, it looks like our Raspberry Pi is, we've really started to lock it down to harden it up a little bit, especially if it's just lying around the office. We should probably take care of this mat. I'm sure some of this hasn't been done. Now, this is not the end-all be-all, but this is the majority use case, right, Don?
Absolutely, yep. So some of the things we talked about here, we created a separate user account for us and disabled the Pi user. We modified SSH to only allow us to use it. We installed a firewall to protect us, and we configured automatic updates. And between all of those things, that is going to protect you from the bulk of attacks that are out there that target IoT devices like these. Now, you can still totally blow your security game out of the water and ruin everything by installing crappy software. So be aware of that, right? The device is only as secure as the software we put on it. But the steps that we just took are going to secure at least the Linux distro part of it about as well as we're going to get.
Well, Don, it's been a great Pi day, and hopefully you go out and find some Raspberry Pis to lock down, secure, and celebrate 3.14. And make sure you subscribe, right? You need to do that. We'll see you next time, but definitely stay tuned. We got more ITProTV coming at you.
Thank you for watching ITProTV.